It's Saturday night. Anyway. Live from New York, it's Saturday night. Just kidding. It is geometry period 1 in Snellville, Georgia. Say hi, period 1. Hi. I know, I'm awful at it. Here we go. So we are looking at question number 20 on the review sheet. Question number 20. This is, if you remember from yesterday when we went over the formulas, we talked about that whenever you get coordinates, almost every single time you're going to use distance. This is one time that you're actually not going to do distance because it wants to know what's the coordinates of the center. So what formula are we going to use if we get the diameter and we need the center? Nope, I just said you're not using distance formula. Midpoint, yep. So midpoint formula is one of the formulas you have to remember. The midpoint formula is you add the x's, divide by 2, add the y's, divide by 2. So -3 plus 5 is going to give you +2. +2 divided by 2 is going to give you 1. So right away we can eliminate A and B because both A and B have -4. Then we're going to add the y's. 5 plus 7 divided by 2. 5 plus 7 is 12. 12 divided by 2 is 6. So it's choice D.
I got that, but I didn't do all that. I just did the 2 points on the graph.
And then you went up and over?
Yeah.
Yep, you can do that too.
So, how do you know?
Yep. So the question on the table is, how do you know if you're not doing distance? Because it doesn't mention anything about length, perimeter, or area. So because it says center, if we draw a picture, this is a diameter, the center is the middle. That's why we know the midpoint formula. But for 21, it says, what's the perimeter? So because it says perimeter, now we know we need to know length. And so now we know we have to do the distance formula. Now, this is one where you're going to want to use your graph scrap paper just to make sure they give you the points in order. So we've got 3, 1. At least they told you it was a rectangle, so we only have to find 2 sides. Then they said -2, -4, -2, -1, and 3. This is my awful picture. -4. Wait, this doesn't make sense at all. Yeah, I just noticed that. Let me see if they have a graph paper insert I can put in. Because that way we don't have to look at my awful. Apparently not. They give us stars, no graph paper. All right, so it looks like it is going to be. So we have 3, 1 here. Let's try one more time. Over 3 up 1, 1, 2, 3 up 1. -2, -4 is down here. -2, +1. There we go. 3, -4. So the reason why we had to graph it is because if you notice, they didn't give us the points in order. So that's part of the reason why we had to graph it. So we know we have to go from -2, +1, over to +3, +1. You can do distance formula, but because the y's are the same, it's just easier just to add it. How do you get from -2 to +3? You add 5. Here it says negative, this is -2, +1. This is -2, -4. So if we're at +1 and we go to -4, again, that's 5. Now, technically speaking, we're subtracting 5, but you're not going to ever have a negative distance. So now that we've got 5 and 5, we can, don't use the Sharpie marker, Michelle. 5 times 5 is, or it wants the perimeter. That's another thing I just messed up on. So because it's a rectangle, we know the opposite sides are the same. So the answer is 20. So you could also sketch it out on the graph paper and then do plain distance formula. But why do the distance formula if the x's are the same and the y's are the same? It's too much work. Just count the boxes. Also, if you put it on graph paper, you could do the Pythagorean theorem and get the length of the hypotenuse. Notice how I messed up. I was going to say like, oh, the answer is 25, but that would have been the area. The question was asking for the perimeter. So look for where they're going to try to trick you. Which of the following cannot be formed by the intersection of a plane and a hollow cube? Basically, it's saying which one of these cannot be a cross section of a cube. So we've talked about this already. For a rectangle, you would have to go on the parallel side. And actually, Michelle. Nope. One more thing. Actually, it's easier for me to show you the visuals. So if we look at this picture, coming up. Okay, so it's on the bottom. Look at the bottom. So notice how if we cut the cube on the diagonal, I'll just move it all up. If we cut the cube on the diagonal, we'll end up getting a rectangle. If we cut a cube on the corner, you'll end up getting a triangle. If you cut the cube going partway on the top and partway on the bottom, you end up getting a trapezoid. And because a cube has 6 sides, if you connect the vertices from each of the sides, you can get a hexagon. So the hexagon is the largest shape that you can get in a cube. So what's the largest shape you can get in a cube? What's the largest shape you can get in a cube? Okay, so which of the following cannot be formed? An octagon. An octagon cannot be formed from a cube. I don't know how a pentagon can be. I can't picture that one. That one we're going to Google right now. What? Apparently it's a boy band. All right, there's the pentagon. Who knew? 1, 2, 3, 4, 5. All right, now we know. Let's put it in here so I know for next year. Okay, back to this. So we know an octagon cannot. The hexagon is the biggest shape. 6 sides of a cube, 6-sided shape. Timmy fills a bowl with cereal and wonders how much is inside. What's the best emphasis, or what's the best estimate? Why can you eliminate A and B? Excellent. So does it make sense that the radius of the bowl is 5 inches or the radius of the bowl is 2.5 inches? Why is it not 5 inches? Well, it doesn't tell you how big it is, but think of it. If the radius is 5 inches, then that means the diameter is 10 inches. So that means that the bowl is almost as wide as this paper, because paper is 11 inches long. So the correct answer is 2.5 inches, because that would give you a diameter of the bowl of 5. Farmer Brown grows corn on his 110-acre farm. The yield on his farm is 17,600 bushels of corn. Farmer Diaz grows wheat on his farm. He plants 250 acres of bushels. What's the density per acre of the wheat and corn? Remember, whenever we do density, it is always going to be things that you can count or weigh over space. And space means area, volume, things like that. I think it was Cameron who said things that you can touch over things that you can't touch. Like you can touch corn and wheat. You can't go and touch 110 acres of a farm at the same time. So if that helps you, great. If not, that's fine. So we've got Farmer Brown. Farmer Brown has, well, we can count corn. So 17,600 over 110 acres. So I've got calculator, 17,600. Nope, We're just solving it to compare densities. We're not looking for a missing number. You cross multiply when you're looking for a missing number. Equals 160 corn per acre. That says corn. Because we're not there yet. This, it wants to know what's the difference in density. So first we have to figure out both densities, and difference means subtract. So then it says that Diaz had 13,750 bushels on 250 acres. So we're going to do 13,750 divided by 250. That gives us 55 bushels per acre. So then finally, this is clearly a DOK2, maybe even a 3, but probably a DOK2. We subtract and we get 105. So Farmer Brown grows 105 more bushels per acre than Farmer Diaz. So again, whenever we do this, we always are looking at things for density that you can touch over things that you can't. I think there's 3 questions on your district assessment relating to density in some way. So this is kind of how we would do it. Can we go on? Okay. Anthony is shipping dice into a casino. Why anyone put a question about gambling on here, I don't know. Each die is a perfect cube with a side length of 0.016 meters. Meters. The dimensions of the rectangle box are shown below. Okay, so I forgot we need to talk about this. Let's talk about this. Whenever we have, I'm actually going to pull it up here because I'd prefer you to see the visual. Here is, hopefully, come on with the power of Google. No, yeah. So here is a metric chart. Open image and new tab. So. Hurry up, open up, you're driving me insane. Remember that I think you guys had told me, I forgot, that you had 1 or 2 questions that dealt with converting. So let's talk about converting. Okay. So you guys told me in August that there was a question that asked you about converting. So let's talk about converting. The main thing that they're going to probably have you convert between is millimeters, centimeters, meters, and kilometers or kilometers. That's what you can kind of expect to see. So what that means is that the center thing, in this case meters, that's always kind of like our baseline. So right here, this meters, I like using red. This is our main thing. That's kind of like the center of the chart. If we go from meters to centimeters, going this way, you multiply. So you have to remember that from starting at meters, going to centimeters, you're going to multiply the meters by 100. So each of these boxes is a base of 10. So 5 meters, well, 5 times 100, that's going to equal 500 centimeters. If we're going from meters to millimeters, that's 3 jumps. So 5 meters, 3 jumps means we're going to have 3 zeros. 5 meters is the same thing as 5,000 millimeters. So this conversion, remembering to jump 2 to centimeters, 3 to millimeters, you're going to have to know this. From you going to millimeters to kilometers, that's the same idea. We're going this way. So we also have to work from there. So let's go back to this question. So here we've got, what is the maximum number of dice? Well, this is in meters. So we have to convert how many meters is there in millimeters. So we know to go from meters to millimeters, we have to multiply by 1,000. So we're going to start off by taking 0.016 and multiplying that by 1,000. because that's going to convert it into how many meters each dice is, or how many millimeters. I got 16. So one die is 16 millimeters long.
Are we really gonna need to do that on the test?
Not you specifically. Someone told me in August that there was a question about converting on the test. Because remember in August you took, or not August, in at the pretest in January. Was it kilometers? So, because remember the pretest is the same as the final. So that's the only reason why I want to go over this, because you guys were the ones that said there was a converting question. So here, so if you're going from kilometers to meters, you also multiply by 1,000. So pretty much you multiply 1,000, except if it's a centimeter. That's the only time you wouldn't. So now that we know it's 16, now what we have to do is we have to divide each one of these sides by 16 to see how many things can fit in it. So going across, we've got 128 divided by 16. So that means that here, 128 divided by 16 means that we can have 8 going across. 96 divided by 16 means that we can have 6 going deep. 288 divided by 16 millimeters means that we can have 18 high. So now all of this is probably a DOK3. All of this is now what we multiply together to get the volume. So I'm going to do 18 times 8 times 6, and we get 864. So let me say that one more time. Please write these steps out. First, you're going to have to convert. And when you convert, we go meters to millimeters. We multiply by 1,000. If you have to do meters to centimeters, you're going to multiply by 100. And if you do meters to kilometers, you're going to have to well, actually, you know what? I'm going to make it say kilometers to meters. If you go kilometers to meters, you also multiply by 1,000. So if you have to go from meters to kilometers, then you'll divide by 1,000. If you have to go from millimeters to meters, you divide. So it depends on which way that you end up going. So that's your first step. Then you have to figure out the sides, and then you would do the volume problem. That problem was intense. All right, next. Come on, what are you doing? Oh, is it the end? Oh, sugar shoots. I didn't realize they still had Epic Pen on. Okay, so that's the end of those questions. I'm going to just rewrite this without the Epic Pen. And then we'll go from there. So I can stop the video.